In clinical settings, most information is not structured or standardized data. It comes from the patient's natural, unstructured language. Symptoms, timing, intensity, and context are all interwoven. Without structure, it is difficult to make this data clinically actionable. Of course, general-purpose AI can analyze what a patient says. However, simply ingesting vast amounts of knowledge does not make an AI suitable for clinical practice. It struggles to identify clinically significant details within complex medical contexts. Right now, what medical AI needs is not more knowledge. It needs the ability to understand clinical meaning in language and translate it into clinically relevant, actionable information that clinicians can trust for decision-making.
AI adoption in healthcare is no longer just a trend. It's an undeniable paradigm shift. However, because we deal with human lives, it is critical to understand the basis of AI-generated outputs and how their quality can be reliably governed.
When we began developing this technology, the question we focused on was this: what defines an AI that is truly trustworthy and safe for real clinical settings?
It wasn't just about summarizing the patient's words. We asked, how can we structure this into clinical meaningful information? And ultimately, how can it serve as a reliable basis for clinical decision-making?
Ultimately, care begins with the medical interview. So, we believed AI must extract key insights from complex conversations to support the diagnostic workflow more efficiently from very beginning.
To deliver the right answers, AITRICS first designed the right question, a method to clear away ambiguity so that our language can turn into clinical data and lead to clear answers.
The right question.
The right question.
The right question.
We call it the right question.
The right question mirrors the clinical reasoning of an experienced physician, logical, systematic, and grounded in clinical thinking.
Having learned from over 200,000 verified scenarios and academic papers, MOCA mirrors the structural thinking process of a medical specialist. But reasoning isn't enough for trust. MOCA systematically builds reliability using our proprietary evaluation standards. We verify and control critical factors. Is the flow of the inquiry concise and appropriate? Did it ask the right questions? Are the answers clinically meaningful? And crucially, are we operating within safety boundaries? Our frameworks for evaluating MOCA have recently been recognized at top-tier AI conferences.
Take HDDX. It goes beyond the simple binary judgment of right or wrong. It evaluates clinical proximity, measuring how medically plausible an incorrect answer might be. If the diagnosis is pneumonia, identifying it as bacterial pneumonia holds far more clinical value than mistaking it for gastritis. HDDX quantifies this nuance. Then there is EPAG. It doesn't judge how well the AI speaks, but objectively evaluates whether it asks every essential question required by clinical guidelines, ensuring no key information is missed. But those asking more questions typically lead to higher accuracy. We believe true performance lies in a concise and coherent pre-consultation flow. That insight led us to publish our research on format inertia.
The clues found this way are transformed into data with clinical value. And in medicine, the transparency of the process is just as important as the result.
The general purpose model cannot guarantee the reliability and safety required in healthcare. That is why AITRICS insists on developing its own medical AI models. We must be able to verify what each answer is based on and directly evaluate and control how the AI performs. We believe confidence in medical quality is only possible when we can fully validate and control the model's performance ourselves.
However, there is a paramount principle that must come before all this intelligence, an uncompromising standard, the very reason technology exists: safety.
Safety isn't just an option, especially in medicine. Simply providing accurate answers isn't enough for medical AI. A true medical AI must be context-aware, adapting its responses based on the intent behind every question.
That's why we built TACOS, a classification system that precisely categorizes user intent into 21 distinct types. We identify the nature of the inquiry first, determine the appropriate safety boundary, and then apply the corresponding response protocols.
Technology that proactively detects risk and self-regulates. AITRICS goes beyond simply blocking risks. We apply active guardrails to guide users toward accurate medical information. In medicine, where life and health are at stake, this is how a medical AI proves it can be trusted.
Our goal goes beyond building high-performance AI. The true medical innovation is not achieved through technology alone, but through trust in that technology, technical quality, clinical reliability, and a controllable AI model. The most reliable infrastructure standing firmly behind every medical decision. An environment where anyone can easily and safely ask the right question for their health. That is the future of healthcare AITRICS envisions.
Technology for safer care, the new language of medicine. AITRICS. Omnicare, powered by AI.